In this video, we're going to learn to solve equations that contain radicals in them. The first step required in solving equations containing radicals is to isolate the radical sign on one side. In this example, we must first move the 1 to the right side of the equal sign. So you can see I'm simply going to subtract 1 from the left, but I also have to subtract it from the right. That gives me the square root of x plus 3 is equal to 5. So the radical sign is now isolated on one side of the equal sign. Now the next step is that we're going to square each side, because by squaring a square root, we're going to simply get the x plus 3 back under the radicand. So we end up with x plus 3 equals 25. And at this point, we're just going to subtract 3 from both sides, and x is going to equal 22. Once we get our solution, we need to check it. We need to make sure it's not an extraneous solution. Because when we square an unknown, we do not know if this will result in a non-solution. So remember, if we start out with a phrase such as -2 does not equal 2, but if we square both sides, we end up with 4 equals 4, which is true. So we do need to check our answer in the original equation to make sure it's still going to work. So if x is 22, I go back to the original equation, which was x plus 3 under the square root sign, plus 1 equals 6. Plug in 22 for x, do the arithmetic. Square root 25 plus 1, which is 5 plus 1, which does equal 6, so the answer does work. Now let's continue. In this new example, there are two radicals. So we will isolate one of them first and apply the method of squaring both sides. In this case, we want to isolate the one with the binomial expression under it. It'll be easier to work this way. So first thing I'm going to do is I'm going to square both sides. So I'm squaring the square root of x minus 8, which will get me the x minus 8 back. But I am going to have to multiply out the square root of x minus 2. Since that is squared, I am basically multiplying out the two binomials. So it looks like this: square root of x minus 2 times the square root of x minus 2. So I'm going to go ahead and continue with my mathematics. So if I multiply the right side, I get square root x squared minus 2 square root x minus 2 square root x plus 4. Keep simplifying. And so now I've got x minus 8 equals x minus 4 square root x plus 4. Now I need to continue simplifying so that I can get the square root of x by itself. So here we go. I'm going to take from the right side, I'm going to subtract the x from the right and do it also on the left. I'm going to subtract 4 from the right and also subtract from the left. And what you will see is that the x's cancel. -8 minus 4 is -12. And now on the right side, I am down to -4 times square root x. Almost done isolating the square root x. I need to get rid of the -4. So I'm going to divide both sides by -4, which is going to end up with the square root of x is equal to 3. So now I'm going to square both sides, and what I'm going to end up with is that x equals 9. So just as before, we do want to check to see if 9 works. So we're going to check it by substituting back into the original equation. So there's the original equation. There was my answer. So 9 minus 8, we'll take the square root of that, equals the square root of 9 minus 2. Just plug it in for wherever is the x. That gives us square root of 1 equals 3 minus 2, and 1 equals 1. It works.